you to all of you for being here today to hear a little bit more about some of the new innovative work we have going on at the Census Bureau. Today in my presentation, I'll discuss how cross-survey modeling, which is a new methodology or technique we're developing, enhances Census Bureau estimates or measures. And so my name is Chase Sawyer. I'm a technical lead for model data product development here at the Census Bureau. And I think that that long title, essentially what I try to do is help our data users get the data they need when the data we publish may not exactly align with what they're looking for. And that's really the reason we've gone ahead and created this cross-survey modeling technique. All right, and as we get started today, we're gonna jump in right away to why we went ahead and developed cross-survey modeling. Then I'm excited that we'll be able to talk a little bit more about how we do this technique and how it works. We'll then dive into what we've created so far, and then we'll end our presentation today by discussing where we plan to be going in the future. All right, and so I've been at the Census Bureau for 11 years now, and just constantly while I've been here, we hear lots of calls from our data users about wanting more detailed estimates. They want more timely estimates, and they want it at the smallest geographical level possible. And we do our best to respond to that here at the Census Bureau, and there's a lot of ideas that are floating around about how we go ahead and do this. And so I've been lucky enough in my career to work on the American Community Survey throughout. I've had some roles where we are looking at improving the survey, and others like now where I'm looking at how we can go ahead and create high quality estimates from it. And we get a lot of ideas about how we can go ahead and implement the creation of more detailed estimates. Some ideas we've heard is, well, just go ahead and blend multiple data sources together, and that will go ahead and get you what you need. Or utilize artificial intelligence and machine learning, and that will get you what you need. And I've been lucky enough to see where some of those ideas work and where some instances they don't work out as well. And so one project that I worked on where we tried blending administrative records or housing records was on the American Community Survey, where we went ahead and essentially replaced survey responses with data that you'd get about housing records from counties or from commercial vendors. And what we saw when we did this experiment was that, okay, blended products on ACS, this seems to work for something when we're looking at like the lot size or whether how much acreage you have for your home. There wasn't much difference for something like that between the administrative records and our respondents. But it doesn't actually work quite as well for concepts such as home value, where we saw that there were major differences between the modeled estimates that we were provided and the responses that we were getting from our respondents. And so that's something that we went ahead and dived in, like, okay, a blended data product would be great, but it doesn't really work to just replace for some topics. And we also hear a lot about utilizing artificial intelligence, and we have these machine learning tools now, right? We all hear about different groups that utilize algorithms to feed us ads or information or keep us scrolling through our feeds. And while it seems like a lot of these tools are very well used in the private sector, we're working on upskilling our staff here at the Census Bureau, and we're learning about these languages and these techniques. We're also being very careful to make sure that we utilize machine learning responsibly when it comes to official statistics, because if you get fed the wrong ad from an algorithm, that's okay, that's low stakes, it's not a problem. But if the Census Bureau were to create an official estimate that had issues with it because of machine learning, that would be a problem. And so we're still developing this idea of how you go ahead and utilize machine learning for official statistics. We are doing a lot, though, to go ahead and create more detailed estimates. And so one data product that I currently work on is the community resilience estimates. And these are modeled estimates of social vulnerability in the population. And we create these estimates by using data from the American Community Survey and pairing that with data from the decennial census and our population's estimates program to create a measure of social vulnerability in the population. And we're able to do this for the entire nation, but also for the states, combined statistical areas such as metropolitan and micropolitan areas, counties, and census tracts. And we do this by looking at 10 characteristics found in the American Community Survey and determining how many of those components an individual has. And so one example of this is without vehicle access. And so as part of the community resilience estimates, or the CRE, we look at whether or not someone has access to a vehicle, because the information we have about disaster recovery and social vulnerability tells us that if someone lacks access to a vehicle, they're less likely to evacuate and are more likely to bear the brunt of a disaster. And so we look at the individual responses. On the right here, you're able to go ahead and see a example of a question from the American Community Survey. And we actually look at these individual and household responses in our data sets, tabulate the total number of components of social vulnerability someone has, and then we use those small area modeling techniques I mentioned to go ahead and create estimates. And this has been really great for us, that we've been able to create this multidimensional measure, that we can do it with 1 year of American Community Survey data, and we're able to get that down to that neighborhood or that census tract level. And so the community resilience estimates really kicked off or got started as part of after the COVID-19 pandemic. We quickly created an experimental estimate in the summer of 2020 and published that to go ahead and show the percentage of the population that might be socially vulnerable to the pandemic. As part of that experimental data product series, we received feedback, and we were able to go ahead and make it more generalizable to disasters in general. And we published a production product not long after that. And after we went ahead and published that production project, we were approached by Arizona State University. And at ASU, the Knowledge Exchange for Resilience was really interested in the idea of, well, you have the CRE, which provides this good general estimate of social vulnerability in the population, but some disasters are different than others. And so are there things you can do to go ahead and adjust to make that estimate for a specific type of disaster? And the group at ASU was most interested in us looking at social vulnerability to extreme heat. And we were able to work with that team and use their expertise and make adjustments to the CRE to create the CRE for heat. And we released that in April of 2023. And the way we went ahead and did that was we actually made adjustments to our components of social vulnerability in the American Community Survey data. We one of the components we look at is unit level crowding, and we adjusted that to be a housing quality metric instead. So instead of just unit level crowding, we looked at unit level crowding, or is the housing structure type a mobile home, because there is literature behind the idea of mobile homes being more socially vulnerable to extreme heat. We also adjusted our no vehicle access flag that I discussed earlier to be a transportation exposure flag. So does someone not have vehicle access in their home, or do they commute to work in a way that would expose them to extreme heat? And we also adjusted our poverty status component to be a financial hardship measure. And so we not only looked at poverty status, but we also looked at, does the household have high housing costs, where the housing costs are more than 50% of the household income. And so we were able to go ahead and put this together and get feedback again as an experimental data product to see what we could do to go ahead and improve it. And one of the main pieces of feedback we got from our stakeholders was that our vulnerability metric for extreme heat was missing one of the primary things, and that we didn't have a measure of whether or not the household had air conditioning. Because if a household is missing air conditioning, they don't have access to cooling within their home. And so we got to work thinking about this, because air conditioning is not a question that is asked on the American Community Survey, but it is something that's in our portfolio here at the Census Bureau, where we ask a question on the American Housing Survey, which the Census Bureau completes for the housing and urban development, to go ahead and see like what is the amount of air conditioning in your home. And so there's a number of different questions, but we essentially started to think through how do we break that down to go ahead and look specifically at air conditioning in the home. And how do we get that from one survey that has detailed information, in this instance, the American Housing Survey, to one that has more geographic granularity. And so in this instance, it would be the American Community Survey. And that's where we came up with the cross-survey modeling approach, that we would utilize the data in the detailed subject matter survey to go ahead and train a machine learning algorithm that could be applied to the survey that had a more robust geographic sample. And we could apply probabilities to each of those respondents. And so when we did this, the solution was done. We went ahead and were able to create an algorithm that would predict the results across the American Housing Survey to the American Community Survey. And the latest version of the CRE for heat, which was released in 2024 for the 2022 data year, has this component of households that are potentially lacking air conditioning as a component of social vulnerability. And so now I want to go ahead and I'm going to spend some time talking through the idea of how do we make this work? How does cross-survey modeling work? And what are we doing to make data go from one survey to the other with the algorithm? And we're able to go ahead and do that with 5 steps, essentially. And so I'll use the CRE for heat as an example of what we did for the air conditioning question. But we started with harmonizing our data sets. We then go ahead and train a machine learning model. We apply the predictions from that machine learning model to the new survey, or to the more robust survey. The data is then calibrated, and we go ahead and we aggregate up that data into a usable estimate. And so when we were thinking about this for the American Housing Survey and the American Community Survey, there was data harmonization that needed to be done. In this example here, we're able to show how we went about taking equivalent categories between the 2 surveys, because the way that they collect data, even on this household education question, is different. The ACS has some more detailed educational attainment bands, and a lot of that has to do with the fact that we're asking that question of all respondents in the American Community Survey and all of the people in the household. And so we went ahead and we harmonized our data sets to make sure that they aligned. And we utilized, at least in this instance, some of the more well-known categories of educational attainment that someone might see in some of our published data products. And this is helpful for a number of reasons. One, it aligns with some of the information we're already publishing, but 2, it also helps ensure that the machine learning model doesn't overfit on a small or a vague category. And we had to do this. This is actually one of the easier examples of what we went ahead and did for the harmonization, but we had to do this for any of the variables that we were going to utilize in the cross-survey modeling. All right, the next step is the training. And so we tried a number of different modeling techniques, such as logistic regression, um, random forest, and extreme gradient boosting. And the one that we landed on to use was extreme gradient boosting. And so the way that this looks as a modeling technique, we essentially take the data set, we separate out that we have 80% that we use for the modeling training, and then we use 20% for a test sample to go ahead and validate against. But we go ahead and run our data through and fit a weak model on a decision tree. The prediction residuals are then reused, and we fit another model and another model. And we take these multiple weak models and create one strong ensemble model that can be used as an algorithm. And when we utilize the data from the American Housing Survey and the American Community Survey, we started off by just really looking at the characteristics on the survey data. And so, excuse me, we looked at things like the year the structure was built, as well as the structure type, household income, among other things, excuse me, to go ahead and create a model. What we found, though, was this on its own wasn't giving us the model results that we were expecting or that we'd want to see. And so to go ahead and improve our model, we actually utilized external data, such as the wet bulb temperature, as well as climate zones and coastal county indicators, to name a few, so that we could go ahead and make sure that the model not only was utilizing information we had on the household, but also information that would help us understand if there was a need for air conditioning in that space. All right, and so after we went ahead and trained that machine learning algorithm, we do the prediction, like I showed a little bit earlier, that we utilize the American Housing Survey and that data, and we know from that survey whether or not a housing unit has or does not have air conditioning within the home. We then use the machine learning algorithm to make the prediction of how we would expect a respondent on the American Community Survey to respond if they had been given that question. And we utilize those predictions to make decisions on whether or not we think that household potentially had air conditioning. The next step that we go ahead and utilize is a calibration step, though, that we want to take all of those predicted values on the American Community Survey and make sure that they align with a benchmark that's trusted and that meets statistical standards. And so with the CRE for heat, we actually utilize data from the EIA to go ahead and look at, and the REC survey to go ahead and see what state level estimates were of the amount of air conditioning in the home. We realized that there was a bit of a conceptual misalignment between the question on that survey that was looking at whether or not the household uses the air conditioning, in the American Housing Survey, which looks at whether or not the household has an air conditioning. And so we went ahead and went back and utilized the division information from the American Housing Survey on whether or not the household had air conditioning. And we utilized this for a couple of reasons. As I mentioned earlier, we want to make sure that our data matches high quality benchmarks. But we also want to make sure for our data users that we don't create duplicative estimates, that there isn't multiple estimates that you can get for, in this instance, air conditioning in the household for a certain place. And so we've aligned the estimates to make sure that they align with the division level. All right, and then specifically for the CRE for heat, the air conditioning prediction was going to be part of this, again, multi-dimensional measure where we look at a number of different components of social vulnerability. And we knew that it was important to make sure that we weren't only looking at the percentage of the population that was socially vulnerable to extreme heat, but the percentage of the population that was exposed to extreme heat. And so for 2022, we aligned that with our data year, and we used two measures of heat exposure as part of our data. The first one we took from FEMA, and we looked at areas where the maximum air temperature had reached or exceeded 90 degrees Fahrenheit for 2 or more days in a row in 22. And so that was one of our heat exposure measures. We also gathered from the National Weather Service the idea of areas where the estimated wet bulb globe temperature had reached or exceeded 80 degrees at any time in 2022. And so we included that as well as an exposure measure, and we utilized both of those when we were creating our final estimates for the CRE for heat. And so for the aggregation step for the CRE for heat, we look at the percentage of the population that has 3 or more components of social vulnerability to extreme heat, and that's published as one data estimate. But we also have this portion where we're looking at that they were socially vulnerable and the county was exposed to extreme heat in 2022. And so that's where you see here that there are these places where there's the dark red, showing that there's high social vulnerability, but there's also a number of counties where it shows a 0, and those are places that actually weren't exposed to extreme heat in 2022, according to those two measures. And so you're able to see that that kind of cuts out some of the area in the Pacific Northwest and through the Rocky Mountains, as well as New England. And so we published this as one estimate, so people were able to go ahead and look at vulnerability and exposure at the same time. We published, though, the percent that was socially vulnerable as well, just in general. So individuals were able to look at that if they had a different definition of exposed to extreme heat. And so we completed this process, and in 2024, again, I mentioned we published this data set, and I thought, all right, well, we've figured this out. We knocked it out. Everyone's got that measure of social vulnerability to extreme heat. We've done our jobs. But we continue to listen to our data users. And the main stakeholder feedback that we received from that process was that there was a need for geographically detailed information of the air conditioning estimates on their own. So people need to break it out, and they wanted to see it both ways. And so to go ahead and meet that need, last week, we actually published the local air conditioning estimates, or LACE, and we published tables looking at the percentage of the population within the nation, state, counties, and census tracts that have and don't have air conditioning within the household. And so now I'm going to actually walk through some of the data that we have for that, as well as a county level example to show why we really saw this this need for a geographically granular data set for LACE. All right, and so I'm here at the state level. You're able to see that there are places that have a higher percentage of the population without air conditioning than the rest of the nation. Nationally, the American Housing Survey has it at about 7% of the population doesn't have air conditioning in the household. But with our LACE estimates, we're able to see that there are a number of states where that percentage is much higher, especially in the Pacific division of the country, as well as Montana, Wyoming, in the New England area, as well as near Four Corners. This is a higher state level rate. And so the state level is actually interesting because, as I mentioned with Rex, we are able to do some benchmarking and see, okay, these estimates kind of pass a smell test. We're happy with these estimates. But like I was mentioning earlier, we have lower level, county level data as well. And so when we look at the county level data, you're able to also see, okay, there's things happening within these states. So one example is especially California, where along the coastline and up in the Sierra Nevadas, we see that our estimates predict that there are more households without air conditioning than throughout the Central Valley or your Death Valley. And so to us, this shows, all right, these are plausible estimates, and they make sense for what we would be expecting on the ground, especially when we're thinking about the idea of need. And then we are able to look at some metro level things and see, okay, the estimates are aligning. They are what we would expect based on the American Housing Survey. All right, and then the last one I want to show here is just an example for Salt Lake County, Utah. And to me, Salt Lake County, Utah is extremely interesting because it actually aligns the LACE estimate aligns really well with the national average, where we predict that 93% of the population has air conditioning in Salt Lake County, or 7% does not. But when we look at the census tract estimates that LACE produces for the county, we are able to see that there are major differences, that towards the western part of the county, where there's a number of new housing builds, the LACE estimates are that there are very few people without air conditioning. But in the places near downtown, or where the housing stock is older, as well as going up into the more mountainous region, there are more people that we predict do not have air conditioning in their home. And so, again, on the face of it, this is a really interesting story where we're seeing, all right, this are estimates that would align with our expectations. But we realize and understand that there are more than 3,000 counties in the nation, and that there are a number of census tracts. And we are very interested in getting feedback from individuals on whether or not the estimates make sense for their county or their region or their area. And having this feedback would be extremely helpful for us as we continue to improve this experimental data product. All right, and so now I'm going to transition a bit to where we are hoping to go going forward. I will say specifically for the LACE estimates, I know we're interested in adding a small area modeling technique where we look at taking the LACE estimates and doing a unit level model to see if we can improve the estimates so that we can improve the timeliness. But there are a number of different concepts that we've received interest on creating these estimates for as well. And so we've been approached by the National Telecommunications and Information Administration about the idea of using cross-survey modeling to create more granular data from their current population survey supplement, which looks at computer and internet use. We've also been discussing internally about the idea of using this to look at program participation in the survey of income and program participation here at the Census Bureau, as well as utilizing it for our household trends and Outlook Pulse survey to measure concepts such as government trust or social capital. And then just to kind of go full circle, we are very interested in ideas that the public have where having a federal data source could help meet needs or help inform decisions. And so we are very interested in the idea and the continuing to work with the experimental data product series to see what our data users need. And we'd love an email from those that are interested in sharing their ideas with us. All right, so that ends the more formal part of the presentation today. I'm very, again, grateful for the opportunity to talk through the work that we've done with cross-survey modeling and what we've been able to do with looking at air conditioning access for small geographic areas. But we'd love feedback. And I think we're also going to go ahead and take a few minutes now to answer questions in the Q&A. And I think we're going to turn time over to Gretchen Gooding to give us some of those questions.
Yep, thank you, Chase. I saw a question just added to our Q&A. Do your modeled estimates have uncertainty? And if so, how is it calculated?
That's a great question. That's actually a question that I'm glad came up because it is something we want to address. To look at the uncertainty, we currently just utilize the replicate weights from the American Community Survey. When we do the calibration step, we found literature that lets us know, like, okay, this should hopefully deal with a majority of the uncertainty from the machine learning model. But we would like to improve that uncertainty measure. And so currently, the LACE estimates don't have a worked in measure of uncertainty around the idea of the machine learning model. But if there are individuals that want to provide feedback as part of the experimental data product series, we'd love to hear more about those ideas of looking at that.
All right, great. Another question is, why doesn't the American Community Survey just add a question about air conditioning?
That's a great question as well. And that's actually something that we heard from some of our stakeholders as we were discussing the idea of cross-survey modeling is like, well, why don't we just add the question? It's that important. And air conditioning is an important question, but it's also important that for the American Community Survey that we're thinking about the respondent burden associated with that survey. It's also extremely important as well to know that it's a process that takes some time to add a question to the survey, and it needs to be supported by a federally mandated need, usually through regulation. And so we thought this was a good way, though, of simulating what we would expect our respondents to have. And so in this way, we're reducing respondent burden from the idea of adding another question. And we're also utilizing some of those techniques that we think are going to be helpful in creating high quality estimates going forward.
All right. Another question, it says, thank you. This is very interesting. Could you please talk in more detail about your trained ensemble model and its components?
Yeah, no, we can talk about that. And so the ensemble model essentially looks at a number of different characteristics. And when we're looking at that, we're looking at things like the accuracy, we're looking at whether or not we need to oversample certain characteristics. And that was something that we needed to oversample for this, is that it is a somewhat rare trait to not have an air conditioning in the United States. And so that was one part of what we looked at was, okay, well, let's do some oversampling here as we're looking at that. And let's look at things like the recall and the accuracy with kind of greater rigor than we might otherwise. And so we're able to go ahead and balance a lot of those things. And then with the calibration step, I think it helped us make sure that we had a high quality estimate that aligned with the expectations for an area. And so those are some of the things we looked at in the machine learning model.
All right. Another question, are all types of air conditioning systems considered or only certain types?
That's a great question as well. And so we utilize any type of air conditioning that's asked in the American Housing Survey. And so that's central air, that's in room air, that's things like evaporative cooling. And so all of those should be accounted for in the estimate because they're asked in the American Housing Survey. We had talked about the idea of, do we only look at central air or do we only look at certain types? But we essentially decided for this that we'd utilize any of the types of cooling that are mentioned in the American Housing Survey.
All right. Of course, once one question gets asked, right now everyone has questions. So let's see. I have to scroll up here. Do you combine the internal and external data and then analyze it or them into the same model? And would you share some strategies for cleaning the data before doing machine learning? Thank you.
Right. And so, no, that's a good question as well. And so we do this on the internal data because we want to take advantage of the fact that we have the high quality data behind the firewall here at the Census Bureau. And so we utilize the data, and a major part of that as well is the cleaning. And so with the cleaning, we're trying to create classes where we don't end up with very small cells to make sure that we don't end up with overfitting. And so that's how we go ahead and utilize some of the internal data. And then, yes, the external data we're bringing in, a lot of it mapped either to the state or the county level. And so we just attach that to our data sets using the geographic identifiers on our data sets. And so those geographic data then end up being more coarse. But as I mentioned earlier, it really helped us kind of square away the idea of what is the need or the demand for air conditioning in those areas. And so those are some of the things that we considered as we were creating the harmonized variables.
All right, let me see. Is or will the methodology for extreme gradient boosting be documented on your website?
Yes, and so that's something we wanted to make sure we had estimates for the summertime. And so we haven't published the Python package that we utilize to go ahead and create this, but we are building it into a package so that someone is able to go ahead and do a cross-survey model on their own, essentially on their own data sets. And so that's forthcoming on our end. We do want to be transparent though and have it, but we're kind of just working through the final steps of, all right, well, how does this get cleared? How do we make sure that we didn't accidentally leave some data in there that is internal? And so we're working through that process now. But then, yes, it wouldn't just even be the air conditioning estimates that we publish the data for. It would be individuals could utilize this on their own as a Python package.
All right. Has this technique been applied to constructs other than air conditioning? And what are some emerging research areas for this technique, and where could I learn more?
Awesome. So we have seen this used a little bit in the private sector or in some nonprofits where they're using extreme gradient boosting to bring data across data sets. And so this is the first kind of, at least for our area here at the Census Bureau, to go ahead and utilize these techniques. But as I mentioned a little bit earlier, we're very interested in the idea of using some of these things for looking at the survey of income and program participation, or helping our stakeholders at NTIA better understand information from their supplement. And so those are things that we plan to do going forward. And then Gretchen, I think there was a last part of your question that I might have missed.
Yeah, it's always hard when you get those two-parters. What are some emerging research areas for this technique, and where could I learn more?
Right. And so I do think we're going to see this more and more as we're trying to blend data products and utilize a number of different high quality pieces of information. And where you can learn more is we have published a number of we published a working paper where we talk about this technique and how we utilize it specifically in the CRE for heat. We've published kind of a blog that people can find on census.gov that talks through how we think about this. And as part of the LACE data set, we published a quick guide, but as part of that, we went through and showed, all right, how reasonable are these estimates compared to some of the other benchmarks that are out there? And so those are all places I would point you to learn a little bit more about what we're doing with cross-survey modeling.
All right, Chase, I'll do one more question. There's a lot of interest in the chat, so I will remind people you do have your email address on here if they want to follow up with you. So last one is, would you consider publishing the raw predicted probabilities as an optional PUMS feature?
Yes, I think I really want to get there. Sorry, the PUMS get me excited because I enjoy using them. But yeah, I think for that, again, we wanted to get the first round out so people could see them, but we definitely do see that as an add-on feature of the idea of like, all right, well, let's walk this all the way through and show on the PUMS how you go from the American Housing Survey to the American Community Survey. And then that way as well, we could provide individuals that synthetic data point as a prediction on the ACS PUMS. And so again, yeah, I'm excited to hear there's interest in that because I know I get overly excited about using the PUMS. But yes, I definitely think that's a possibility for us to do in the future. And hopefully that would help kind of augment some of the data that we publish using the American Community Survey PUMS. All right, and then I guess considering that was our last question, I'll take a moment again to thank the participants today. I'm very grateful there was interest and people wanted to learn more about this. And again, please reach out to us if you have a question or a suggestion or feedback, because that really helps feed our program. And so that email is provided there. It's sehsd.cre@census.gov. And thank you, everyone.